Hello students, in this video you are going to learn about different reaction of alkynes, and I am preparing this video according to syllabus of NEB, NEB syllabus. So you will be learning about addition reactions of alkynes and acidic nature of alkynes. And under acidic addition reactions, you will be learning about these four different types of reaction or four different reactions: addition of hydrogen, addition of bromine, addition of halogen acids, and addition of water in the presence of mercuric ions. Similarly, in another topic, acidic nature, you will be learning about reaction with sodium, reaction with ammonical silver nitrate, and reaction with cuprous chloride. Okay. Addition reactions. So like alkyne also show addition reactions, right? So because of presence of pi bond, alkyne also undergo addition reactions. So however, you note down that the addition reaction in alkyne, they are quite slower as compared to addition reaction in alkene. Okay, so faster. So addition reaction in alkyne, they are quite slower than in alkene. Please note down this thing. Now let me explain about the addition of hydrogen. So addition of hydrogen is achieved in the presence of catalyst. In the presence of catalyst like palladium, nickel, or platinum. All right, palladium, nickel, or platinum. Now let me explain the process very briefly. So at first, hydrogen gas is passed under high pressure over this catalyst surface. Let's say this is nickel, and hydrogen atom, they will adsorb, okay, on this catalyst surface, and then alkyne is passed over this catalyst surface, and this alkyne will add the hydrogen one by one, right? So it will add the hydrogen on this in its molecule. So it will at first give alkene, it will change into alkene. Again, same process gets repeated. Next molecule of hydrogen will add in the presence of nickel, and it will finally give alkane. So this is the key concept. Okay, so alkyne will add altogether 2 molecules of hydrogen to give alkane as a final product. This is the key concept. Initially alkene is formed, and again the process repeats and alkane will be formed. Now let me explain you. Let me give you example of chemical reaction. So ethyne, let me give you example of ethyne at first. Ethyne, CH triple bond CH. When ethyne is passed on the catalyst surface containing hydrogen, so it will first change into ethene, and as you can see here, one hydrogen atom adds here, another hydrogen atom adds here, and one pi bond will break in this process. Okay, now there are two bonds, one sigma bond and one pi bond. Again the process gets repeated. H2 nickel, okay, again it will give CH3 single bond CH3. So in this way, ethyne converts into ethene at first, and then finally into ethene. Okay, so this reaction can also be written like this. So in single step, we can also represent this reaction like this. Altogether 2 hydrogen molecules are involved, right? So 2H2 in the presence of nickel, so it gives CH3 single bond CH3. So in this way also we can represent this overall reaction. I hope you understand. Now let me show you one more example from propine, C triple bond CH, propine. So propine reacts with hydrogen in the presence of, now let's take platinum as a catalyst. So one hydrogen will add here, one hydrogen will add here, and one pi bond will break. So it will give CH3 CH double bond CH2, right? So again the process gets repeated. Platinum, so one hydrogen will add here, now one hydrogen will add here, so again it will give CH3 CH2 CH3. Now finally it will give alkane. So propine converts into propene, and finally into propane. So I hope you understand. One very important question: So identify the products A and B. You are given but2-wine and you are asked to find A and B. Now the combination which is given here, PDBSO4 quinoline, this is called Lindlar catalyst. Okay, this is called Lindlar catalyst, and this will stop the reaction in alkene stage. Okay, so it will stop in the alkene stage. So it means now A means C double bond C, there is CH3, now 2 hydrogen atom will add from the same side. Okay, from same side, so it will give cis but2. So this is cis but2. And what is B? B means trans but2. Okay, so here CH3, 2 hydrogen atom will add from the opposite side. The mechanism is such that the 2 hydrogen atom will add from the opposite side and it will give trans but2. Alright, so these are the answer or structure of A and B. I hope you understand. Now addition of bromine. Now as you can see in the first picture, bromine, it is reddish brown liquid. Okay, and when alkyne like acetylene is passed into this liquid bromine, or propyne is passed into this liquid bromine, or let's say butane is passed into this liquid bromine, whatever. So the color of this bromine, reddish brown, will turn into colorless. Okay, it will change into colorless. Now let's see the chemical reaction, why it becomes colorless. So there occurs addition reaction of bromine. Let me write here equation. So CH triple bond CH. So this is ethyne. So when ethyne reacts with bromine in the presence of solvent CCl4, then one bromine will add in this molecule, one bromine will add in this in this atom, and one bromine will add in this atom, right? So it will give CH bromine here, double bond CH bromine here, one pi bond will break. So again it will react with another molecule of bromine, and one bromine will add here, one bromine will add here, right? So it will give CH Br and single bond CH Br. So what is the name of this final compound? So 1,1 2,2 tetrabromo ethane, right? Tetrabromo ethane, BROM, tetrabromo ethane is formed. So 1,1 2,2 tetrabromo ethane is formed as the final product. So I hope you understand addition of bromine. Addition of HX or addition of halogen acids, HCl, HBr, HI, they are called halogen acids. Okay, now let's see some example. Ethyne, CH triple bond CH, when ethyne is treated with HCl, at first it gives CH2 double bond CH and Cl, right? So one hydrogen atom add to this carbon and another chlorine atom add to this carbon, and one pi bond is broken. So in this way this product is formed, vinyl chloride. Again, since there is one more pi bond there, so again it will react with another HCl molecule, and now since it is unsymmetrical alkene, we have to follow Markov-Nikov's rule. So the H plus will add to this carbon which has more number of hydrogen, and chlorine will add to this carbon which has lesser number of hydrogen, right? So according to Markov-Nikov's rule. So the product will be, final product will be CH3 single bond, and this pi bond will break. So CH Cl and one chlorine atom will be added here, Cl. So this is the final product. The name of this product, 1,1 dichloro, 1,1 dichloroethane, right? 1,1 dichloroethane. This is the final product. Let's see one more example. Propine CH3C C triple bond CH propine HBr. Now I'm going to take example of HBr. So this is unsymmetrical, so here we have to follow Markov-Nikov rule again. So H goes to this carbon which has more number of hydrogen, and Br goes to this carbon which has lesser number of hydrogen. So now it will give CH3C, here Br, double bond CH2, right? Now again, since there is one more pi bond, it will further react with HBr, and it will give CH3. Again, according to Markov-Nikov rule, H goes to this carbon which has more number of hydrogen, and Br goes to this carbon which has lesser number of hydrogen. So our final product becomes CH, Br, CH3, CBr, again here Br, and here CH3. And name of this product is 2,2 dibromopropane. Okay. So in this way, addition of halogen acids occur in alkyne. I hope you understand. Addition of water. Okay, now fourth reaction, addition of water. Now it is carried out in the presence of mercuric ions and dilute H2SO4. Okay, and this is very important reaction because from here we can obtain aldehyde. All right, we can obtain aldehyde or we can obtain ketone. Depending upon the starting molecule, we can obtain either aldehyde or ketone. So if our starting molecule is ethyne, 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 we can obtain aldehyde from this reaction. And if our starting molecule is other alkyne, any other alkyne, then we can obtain ketone as a final product. Okay, so this is very useful reaction for preparing carbonyl compounds. Now let's see chemical reaction. CH triple bond CH. So this is ethyne. I am starting with ethyne. When it is allowed to react with water, H2O, and the reaction is carried out in the presence of mercuric ion, 1% GSO4. It is carried out in the presence of dilute H2SO4, okay, 20% H2SO4, and the reaction mixture is slightly warm, so 80 degrees Celsius. Now it will give CH2 double bond CHOH. Okay, how this product is obtained? So it's very simple. H goes to this carbon and OH goes to this carbon, right? H2O means H and OH. So H goes to this carbon, OH goes to this carbon, and Y pi bond gets break. Yeah, one pi bond gets break. So this product is formed. CH2 double bond CHOH. Vinyl alcohol is formed. Now this vinyl alcohol undergo rearrangement. Okay, rearrangement. We call it 1,3 rearrangement. 1,3 shift of hydrogen. So hydrogen from this oxygen will shift to this carbon. Okay, 1, 2, 3. We call it 1,3 shift. So now rearrangement occurs, or we can see hydrogen shift. Okay, hydrogen shift, HYDROG in hydrogen shift, and it will give CH3 single bond CH double bond O. Okay, so in this way acetaldehyde is obtained, or ethanol is obtained, ETHANL, ethanol is obtained. So I hope you understand. Let me show you one more example. Propine, C triple bond CH, propine plus H2O in the presence of mercuric ion, Hg2 plus, in the presence of dilute H2SO4, and slightly warm. So as previous reaction, H goes to this carbon which has more number of hydrogen, and OH goes to this carbon which has less number of hydrogen, right, according to Markov-Nikov's rule. So we will obtain this product CH3 C, here OH double bond CH2. So one pi bond gets break, and it will give this product vinyl alcohol, right? Now this molecule is quite less stable and it undergo rearrangement, or 1,3 hydrogen shift. Hydrogen atom shift from position 1 to position 3, 1 2 3, position 1 to position 3, and this pi bond will shift here, okay, this side. S goes to this carbon and pi bond goes to this side. So it will give the final product CH3 C double bond O single bond CH3. So we obtained ketone, and this ketone is called acetone. Okay, this is acetone. So in this way, propine finally gives acetone or ketone. I hope you understand. Acidic nature. Ethyne and some terminal alkynes, they show acidic behavior. You know, one characteristic of acid is acid, they react with active metal. They react with active metal and they give salt and hydrogen gas, right? In similar way, alkyne also, some alkyne, they also react with active metal like sodium, and they also give salt and they also give hydrogen gas. Okay, so showing acidic behavior. Now let's see some chemical reaction. Ethyne, CH triple bond CH ethyne. When ethyne is allowed to react with sodium in the presence of liquid ammonia, sodium liquid ammonia, so it will give CH triple bond C minus Na plus, and this H will be obtained as hydrogen gas. Okay, hydrogen gas. For balancing, I am keeping here 1/2, and this product is called sodium acetylide. Sodium acetylide. Okay, sodium acetylide. Now let me give you another example. Propine CH3 C triple bond CH. Okay, propine in similar way reacts with sodium in the presence of liquid ammonia, and it will give CH3 C triple bond C minus Na plus and hydrogen gas, right? And this product is also called sodium methyl acetylide. Okay, sodium methyl acetylide. Sodium methyl acetylide. So I hope you understand. Reaction with ammonical silver nitrate. Okay, ammonical silver nitrate means silver nitrate plus NH4OH. Okay, mixture of silver nitrate and NH4OH. It is also called Tollens reagent. Okay, we also call it Tollens reagent. Tollens reagent. So when alkyne, acidic alkyne, especially acidic alkyne react with Tollens reagent, then white PPT will be formed. White PPT of silver acetylide will be formed. Let me show you chemical reaction. Ethyne or acetylene plus silver nitrate plus ammonium hydroxide, yeah, ammonical silver nitrate. So it will give C triple bond C. So this H will be displaced, okay, plus minus Ag plus, and as a byproduct ammonium nitrate, and as a byproduct water will be formed, and this product is called disilver acetylide. Okay, disilver acetylide, and it is a white PPT. It is a white PPT insoluble in water. Okay, white PPT, disilver acetylide. For balancing, you can keep here 2, and here 2, here also 2, and here also 2. So it will be balanced. Okay. So I hope you understand. So this reaction is very useful for identifying or for confirming the terminal alkynes and ethyne gas. If it is terminal alkyne or if it is ethyne, then obviously it will react with ammonical silver nitrate and gives white PPT, which confirm the presence of ethyne or terminal alkyne. Reaction with ammonical cuprous chloride. Okay, so ammonical cuprous chloride means, once again, Cu2Cl2 plus NH4OH. Yeah, mixture of ammonium hydroxide and cuprous chloride. We call it ammonical cuprous chloride. Now, when terminal alkyne or ethyne reacts with ammonical cuprous chloride, it gives red PPT. Okay, it gives red PPT of copper acetylide. Red PPT is formed, which indicates presence of terminal alkyne or ethyne. Let me write the chemical equation. CH triple bond CH plus Cu2Cl2 plus NH4OH, right? So it will give C triple bond C minus copper plus minus, so it is a red PPT, right? So red PPT plus ammonium chloride NH4Cl and H2 as a byproduct. Okay, and name of this compound is dicopper or dicuprous, whatever you say, dicuprous, CuProus, dicuprous acetylide. Okay, and it is a red PPT. So when acetylene is passed into ammonical cuprous chloride, it gives red PPT of dicuprous acetylide. Now for balancing, you can keep here 2, here also 2, and here also 2. Now the reaction is also balanced. I hope you understand. And from this reaction also we can distinguish between terminal alkyne and non-terminal alkyne. Terminal alkyne will produce red PPT, whereas non-terminal alkyne will not give red PPT. I hope you understand. These are some important questions. You try yourself and show to your teacher.